So I want you to look at those near resonance conditions in applications. And these are very important because that's the whole point of doing this ME147, that you should be aware of vibration and systems and then their applications. There is also some possibilities of pendulums. And in pendulums, what you covered two things. You can derive model equation. You derive model equation, right? By energy conservation. Look at those. Energy conservation, and you also have derived equation by using F is equal to sigma F is equal to MA. Now, this system and model equations were not difficult to derive. What problem appears when your pendulum is also attached with some springs at some side? Inverted pendulums I gave you, which is very unstable. And this is, I have given you chapter 3 notes. Look at that, chapter 3 notes. There are examples in chapter 3 notes. So look at those model equations and see how they work, what is happening. I will also urge you to look, and believe me, there will be a question, and I am telling you now that if you have system, something like that, some K, K1, K2, K3, and then I really ask you M to M or some etc. And I ask you really to solve it, derive the equation. So here you need to, for example, you derive the equation. And then you can derive your omegas, your lambdas, your eigenvalues. You will derive your eigenvalues. And then you ultimately reach to those type of things, these diagrams. We have covered that many times, and I have given you in class assignments. I have asked you to solve it. So this is really something which is important. Rotating machinery has only one formula. There is not much we have done. Just I asked you that if something is rotating at the center and the mass is dislocated by some distance and the whole machine is rotating, right? So you have something here, something here. You may have something here. Rotating machinery, unbalanced rotating machinery. It's very important because this is exactly what you will get. You will put in industry some machine which is rotating with compressor or turbine, and you put it on the floor, and then I'm going to ask you what kind of, how to suppress how to minimize, what are your suggestions to minimize the vibrations, suggestions. Minimize vibration, dump the vibration, how you do the dumping. Right. This is all line by line we have covered. We have covered all these all these things. It will be extremely important for you to do and look back solved examples. This is in the book, section 1, solved examples. Look at the book which we are following. Barry's book, Professor Bray. So look at the solved examples. Check them, do it once and see what you are getting. This is the one I would like to cover in my questions. Some parts will come, part A, part 2, part 3. It's a long exam, so there will be a pretty thorough investigation of these things. Now this is really important. One question will come like this, I tell you now. This is coming. So you have to redo it at your leisure time. That how you set up your equations, how you convert them into matrices, how to find out the determinant, how to make it zero, get a characteristic equation, solve the characteristic equation to get your lambda 1, lambda 2s, and then omega, omega 1, omega 2, omega 1, omega 2, and then you go back from there, the values. This is important. That is really very important to do. The problem appears when you put things in the wrong way in the matrix, then the determinant goes wrong. The determinant goes wrong, you open the determinant either in the wrong fashion or the matrix was wrong, so everything is the characteristic equation you cannot solve. This is the main problem. This is the main problem for this question. For example, if I don't say that there is no force here and there is a force here, then the equation completely changes on this side. But if I say this is twice of that, equation changes. If I do not put a spring here, equation changes. If it is open, equation changes. So you have to make sure that what is happening in these cases. One thing which I have not mentioned but I would like to add is that if in these cases, if you are really applying some force here or some excitation force here, that one question will be from here, guaranteed one question will be from here. This will be definitely a question where I will give you y is equal to sine or cosine or whatever, and I will say that okay, this is something which is exciting, and then we are pulling it with some force, and then there are some initial conditions, and there are some conditions which the people who came late, I tell them that again that your marked papers will be in the office tomorrow.